Hi, it's Charlie Zeiss with Stargate Pyramids and the Pyramid Science Foundation. The title of today's video is The Potential Role of Phi-Based Implosion Geometry in Nuclear Fusion. This video is an outgrowth of some research that I did several weeks ago about fusion and the potential applications of some of this geometric knowledge that I've come to find out into this industry, and I've expanded on that. I presented this with Sasha Stone a couple of weeks ago, and people were very enthusiastic about it. So I decided to make this into a larger video. So without further ado, I'm going to open up my screen and we can begin. This information is largely, this video is largely designed for people who are in the nuclear industry and don't know a lot about the information that I put together, but we need to go over that to form a basis, particularly within the energy industry, so that people can see that there's a rich history of the use of this geometry in nature and also by mankind in free energy contexts. So let's just start off with an introduction, and we move forward from here. On December 5th, the National Ignition Facility at the Lawrence Livermore National Laboratory achieved a milestone in nuclear fusion by successfully achieving the first nuclear fusion ignition. And during that test, 3.25 megajoules of energy were produced from a total energy input of only 2.15 megajoules. Now, although that experiment met the definition of ignition, it does not consider the roughly 99% of energy lost in converting electrical energy into the laser energy that was used to fuel the transaction. When viewed from an all-inclusive perspective, therefore, there were 322 megajoules of energy required to produce 3.25 megajoules of energy output, which is a far cry from being over unity, which is the terminology most free energy folks are used to in terms of using it as a term to relate the total energy input versus the total that was extracted. Now, unlike most, or many at least, privately funded fusion technologies, the NIF technology does not employ implosion concepts of any sort. Rather than using implosion geometry and implosion physics, large amounts of laser energy are used to superheat the energy pellet. We're going to see, you saw that on the front page, to temperatures many times those that are really necessary on the sun or in a star to create fusion. However, based on, we're going to talk about this later, the Lawson criteria, higher temperature will compensate for the lack of continuous implosive gravitational force of the sun or on stars, and that's the reason why they need such high temperatures. Now, using large amounts of energy as the primary source of fusion ignition is counterintuitive if, and this is the big if, less energy-intensive means of increasing plasma density and compression times are available. And this is where I believe Phi-based implosion geometry could play a significant role. Now, this video will demonstrate some Phi-based implosion geometry in both contemporary and historical free energy technologies. We're going to know, most of us will know about all these contemporary technologies, but we're going to find it in nature. We're going to find it in contemporary technology as well. So after we've done that review, and that's going to be significant, I'm going to go back and we're going to highlight 5 specific fusion technologies that could possibly benefit from the incorporation of this geometry. So hopefully this information is going to provide the impetus for future researchers to at least consider trying Phi-based implosion geometry in their future fusion reactor designs. So let's get going. Now, most of the architectural information is coming from a book that I wrote last year called 76.345. exploring the hidden secrets of the golden ratio. I've got over 1,000 photographs in here demonstrating this geometry was known by mankind, used for free energy, health and longevity for thousands of years. And they had this knowledge and used it, but yet today, for some reason, we seem to have lost knowledge of this technology. Now, I make Russian pyramids for sale at a company called Stargate Pyramids. That's how I got involved with this. Before I could ever start making them, because the Russians were not allowed to put their research out into the Western academic press, I had to kind of reverse engineer the sacred geometry that was involved with these pyramids. We knew that sacred geometry was involved and that the golden ratio specifically was involved. But because of their inability to publish this information, I had to basically reverse engineer it. And I did that, if you look at the light blue arrow, by thinking of in 2 dimensions, circles, 3 dimensions, spheres. If I took a sphere with a diameter of 1 and I started stacking spheres on top of it, whose diameter itself reduced by phi, or the golden ratio, which is 1.618033399, and it goes on forever. But anyway, if I did that and then built a triangle in 2 dimensions or a pyramid in 3 dimensions, would that possibly match the geometry of the Russian pyramids? And sure enough, it matched up perfectly at 76.345 degrees. Now, although we're not going to get into this angle at the base of the Russian pyramids perfectly matches the apex angle of the pyramids in Giza. And that is a significant discovery, but one we're not going to talk about in this video. Now, what I also want to show you is how profuse the use of this geometric angle is in fundamental scaling properties in nature. You know, first we can look at the refraction of light through a glass sphere. It refracts at exactly this 76.345 angle. We can't see sound, but an object, a megaphone, which amplifies sound, has this geometry as well. We see it in in a swirling vortex of water, a whirlpool, and we even find it in our DNA. So we know that it's fundamentally significant. But perhaps more important to our discussion today is finding this in very powerful implosion events in nature, such as tornadoes. Now, not every tornado is going to have this, but when you go out and look for pictures, do this on Google or Bing Images. When you see a well-developed tornado funnel, you're going to be able to measure it, and you're going to find that this geometry is spot on with the geometry of these tornado funnels. So it has to be important in nature in the implosion process. All of this information has led researcher Dan Winter, who's been a leading proponent of implosion-free energy technology, to state recently that the 76.345 degree angle is what allows you to implode plasma. So with that, I want to start reviewing a few of the 20th century free energy technologies that we're pretty much all aware of. The first one I want to talk about is the research with Viktor Schauberger and his Phi-based implosion physics. Schauberger realized that there were 2 forms of motion in nature, outward and inward. The outward motion is expansive and destructive, whereas the inward implosive motion produces coolness, suction, and powerful vortices. And contrary to his contemporaries, who promoted the use of explosive technology, Schauberger promoted and used the concept of implosion technology. And the 76.345 degree angle can be found in all of his implosion inventions and drawings. So we're going to look at a few of these. Perhaps the easiest one to see is Schauberger's Vortex Home Power Generator, which supposedly achieved 10 times over unity. And remember from our previous discussion, that means that if you had 10 units of energy that you had to input into the system, you'd get back 100. So very, very powerful and he used this geometry in conjunction with the implosion of water. So we can also see he was a great observer in nature. And one of the objects that he loved watching were fish and trout specifically. And in the top right-hand corner here, we're going to see this was really the motivation and inspiration for a lot of his understandings were fish. And you can see that this geometry is found on the back half and the front half of the trout's physical makeup. So he used that geometry and that knowledge in a variety of different technologies. Bottom right-hand corner, these are some drawings of some objects that he placed into water pipes to increase the flow of water through the spiraling vortices of 76.345 degrees. Now in the center, this is called I believe the repulsine technology. I'm not sure if that was ever built, but we find that geometric angle here as well on the back of that device. And then on the left, we're going to see the Heinkel jet aircraft. It was the first jet developed in the world, and it was developed in Germany. Heinkel, the developer, apparently stole a lot of Schauberger's technology, and we can see that in the geometric angles in the various places on the airplane. So we see this 76.345 geometry everywhere through Viktor Schauberger's work. Now the Russians government actually helped to fund the Russian pyramid research over the last 30 years, and one of the key components of that research had to do with free energy. And in summary, this geometry, if the ionization field from the pyramid were to be reproduced electromagnetically, it would require the combined energy generating capacity of all of the power plants in Russia. And that's enormous. And ionization, we're going to keep hearing that term. Ionization fields are the first stage in implosion. In a fusion transaction, the nuclei are not going to fuse until the other stages have occurred first. And one of those first stages is the creation of an ionization field. So we can see that these pyramids, Viktor Schauberger's using this geometry, they're using this to organize energy to implode it. And the second half of this, capacitors were attached to the top of the pyramid, and they spontaneously charged and blew upward into the sky. The energy field of the pyramid could be detected up to 185 miles away. So this geometry is very, very powerful. Here's some other research that was done. It's not very well known in the West because you can't get access to it. Even though the Library of Congress has it, they won't send it to you. So this is a research of a Russian torsion physicist named Anatoly Akimov, and he did research on Phi-based free energy technology. And what he saw, or what he quoted in this article, he said that the geometry of the physical vacuum, and I'm going to say the ether here to help translate, is distorted by means of macro bodies or objects of a certain size and shape, and thus spinor or torsion fields of considerable strength can be created. Now, here's the key point. If the bodies have geometric dimensions with fulfillment of the golden section or golden ratio or phi, then they can play the role of concentrators of the spinor field, or translated, free energy generators. Now, maybe that explains why I had to go to London to get copies of this article, but you cannot get this article in the United States, but it exists, and just further confirmation that sacred geometry plays a major role in the creation of free energy. Now, here's another example. This is Nikola Tesla's Wardenclyffe Tower. In 1905, Tesla filed a patent titled The Art of Transmitting Electrical Energy Through the Natural Medium. The design that he used in the patent became known as Tesla's electromagnetic pyramid, which finally culminated in Wardenclyffe Tower. And that pyramidal design incorporated 76.345 degrees Phi scaling geometry. So we've found this geometry now in three major technologies of the 20th century that dealt with free energy. Now we're going to go back one step further to the work of John Keeley, not as well known, and there's not a lot of his information that's available, but a few of the diagrams that are available from his original work indicate not only did he incorporate it, as in the right, in his machines, but he was also aware of the concept of the vortex and drew this diagram of a vortex with the perfect geometry of 76.345 degrees. So he was obviously aware of this as well. Here's another example of Great Zimbabwe ruins. These are in South Africa. The only reason I'm bringing these up, Dr. Samus Monagich and Michael Tellinger measured a very, very large ionization field, similar to that of the Russian pyramids. And research at the University of London has indicated that ionization fields will improve significantly immune function, which explains a lot of the reasons why the Russian pyramid research as well creates health and well-being for those in the fields. Here's an example of a Sardinian nuraghi. Sardinia is an island in the Mediterranean Ocean. There are at one time there were upwards to 20,000 of these that were on the island. I think there's about 7,000 of them that are still viable, or at least in some sense of array, of organization. They haven't completely fallen apart. But what's interesting, Sardinia, no one's measured ionization fields here, but Sardinia is a blue zone, which means it has one of the highest life expectancies on the planet. And I do believe that it has to do with the ionization fields that come off of these Sardinian nuraghis. Here's an example of a southern Indian Hindu temple. That's called the Dravidian style. This is the Thiruvannamalai Hindu temple. Researcher Praveen Mohan up in the top left-hand corner here has done a video indicating this is a drawing of what looks to be like a Tesla coil that's actually embedded in the ground underneath this temple. On the right-hand side, we're going to see at the top, we're going to see a blow up. These 13 balls most likely contain mercury at one time, and mercury is excited by these types of energy fields and may have been, and probably was, a way of harnessing free energy in this complex. Here's another example, Royal Palace in Phnom Penh, Cambodia. Got this geometry. Also notice in the right-hand corner, this is from a video on YouTube demonstrating that this palace, even today, creates free energy. Here's the Mahabodhi Buddhist temple in India. Notice the slant angle of the temple itself, as well as the coil at the top of the temple, all contain this geometry as well. Here's another example of technology. This is kind of a hemispherical dome structure, which is seen in a lot of stupas in Sri Lanka and surrounding areas in Asia. And they all contain this geometry as well. Synagogues had this geometry. Mosques have this geometry. Gothic cathedrals. This is the Ulm Cathedral in Germany, the tallest church in the world. And, it contained this geometry as well. We can see this, what I believe is Antiquitech. This was all probably part of the free energy technology that we've lost over time. All of the castles around the world, virtually all of them, the domes have this geometry as well as fractal antennas and other Antiquitech. Bell towers around the world, because it can amplify sound, this geometry is used in virtually all the major bell towers around the world. All of the Egyptian obelisks have this geometry at the top as well, as does Tartarian architecture. which is a classic examples of free energy technology here. We've got fractal antennas at the top with wires coming down. We've got mercury balls. We've got potential capacitors in this geometry as well. So there's plenty of antiquitech there. Most of the towers around the Kremlin itself have this geometry, as well as numerous churches throughout the world, Russian Orthodox churches and other architecture. Now, moving forward into the 19th century, I want to start to focus on current tech now. We're going to see this is an iron furnace. The Cornwall iron furnace was the very first iron furnace in America. It used this geometry, all of these, to optimize airflow and maximize the heat generated inside the furnace. Here's an example where it was transferred. This is the Sibley tent stove in the Civil War 19th century period. You could vent this outside, put the stove in, and with minimal amount of fuel, you could keep your tent warm in the wintertime. Interestingly enough, here is the Erlenmeyer Flask. This is not a place where you'd necessarily expect to see this, but I don't think this is an accident. Inventor Emil Erlenmeyer was an expert in organic chemistry and knew a lot about how to create double bonds to essentially increase the energy in a molecular structure. And I think that he must have known in some way that this geometry helped in that process. Native Americans knew about it. All of their arrowheads and the fletching contain this geometry as well, as do bullets, rocket ships. SpaceX has it, all of the jet aircraft. This is our experimental, Lockheed Martin's experimental hypersonic craft. They all have this geometry, as do submarines and other nautical vehicles as well. And finally, hyperboloid structures. In the center, we're going to see the power plant cooling tower. This is a universally seen geometry. All of the major nuclear and coal-fired plants use this to get rid of the heat in the water so that the water can be recycled and used over again in steam generation from these two power sources. On the left is what's called the Shukov Tower, and on the right is actually an observation tower at the Gettysburg War Memorial for the Civil War in Pennsylvania. But all of these use this geometry. Interestingly enough, it seemed this is also used for water towers. Anything that needs to hold an extreme amount of temperature to get or load, like a water tower, will often also use this geometry as well. So now it's time to get into our fusion discussion with that as background. But one of the again, we're going to go back to the Lawson criteria. The successful fusion reactions are a function of the amount of plasma density that can be achieved, the confinement time of the reaction, and the temperature of the reaction. And those three components can be kind of interchanged within limits to achieve fusion reactions. So increasing one or two of these variables can reduce the required amount of the other variables in the equation. So my thesis here is that the increased plasma density and confinement time potentially available from Phi-based implosion geometry could significantly reduce the energy required to initiate fusion, as well as increase energy output. So that's the basic thesis of this. We've seen this in so many other examples now. So let's take a look at how first this is being done at NIF, and then 5 potential situations where this could be used. Now, this is the example of NIF ignition as they did it on this successful ignition back in December of 2022. You've got 192 lasers, 96 up top, 96 at the bottom, and they are beaming into a small cylindrical device that's really not a whole lot bigger than the eraser on your pencil. And that's called a hole round. Now, this hole round is actually taking those rays when they strike the outer or the inside of the cylinder. It converts those rays into X-rays, which then in turn heat the pellet inside. You can see there the white object in the center of the hole round. Now, they've been experimenting with this, and they keep experimenting with new things. Here's an illustration of a newer technology where the interior of the hole round is structured more like a rugby football design. And it's one of several new designs that, they're exploring at NIF. I certainly think that they could use implosion technology there. I've written them, I haven't heard back, but they could certainly, potentially use this as well. But now I want to go into some private industry potential applications and show you where this technology may fit in. And those 5 companies are TAE, Helion, General Fusion, First Light, and Helicity. So this is a picture of TAE technologies. If you can look here in the middle, you'll see these 2 bright objects that kind of look like cigars. Well, those are actually, I caught this right before they imploded in the center from a video on TAE technology. And they originate from either side, and then they are propelled together in the middle. And so there is, I think, some real potential for using implosion geometry in this context to see if this could improve efficiency. Now here, though, is one that is just perfectly made for this kind of an idea. Helion fusion, as you can see, they are imploding. They take a torus on each side, a plasma torus, and they push it through magnetism together. They implode it in the center here. This is just a model, so the fact that it looks as though they're using this geometry may or may not be accurate, but I would imagine that even if this concept were to be refined and improved upon, that they could get improved results from their fusion transactions. Now, this is another company called General Fusion. In summary form, there's a cylinder, and they put their gas or their plasma into the center, and then these red pistons, both I guess the small ones and the large ones, can compress the space or compress that area and bring that plasma together and push it together. Now, I think as well that this concept would perhaps work very well with the use of 76345 implosion geometry. Here's another one, First Light Fusion. Their concept is to if you go to the upper right-hand corner here, you see this little wafer floating in the sky or in the air. That is the projectile that they project through this long tube into, in the bottom left here, you'll see this, this is their energy pellet, so to speak. And in the middle is some hydrogen that's trapped in a bubble. Now, on the bottom right-hand side, you can see that wafer on the left just about ready to implode into the First Light Fusion energy pellet. Now, I feel that when you look at the video, there's nothing to contain this reaction, particularly within the proper geometry. And I think that you could perhaps develop a system where you had this conical structure, coming more or less to a point in the back, and you could theoretically even have a similar conical structure being projected such that it implodes within this very geometry. So I think there's a lot of potential there as well. And then lastly, the one I want to talk about is Helicity Space. This is not technically a company that is working on fusion for energy generation on Earth. They are looking specifically to develop space propulsion. And their technology is called magneto-inertial fusion, very similar to the technologies, for example, that Helion was using. But again, it looks as though their implosion geometry is close to what we are suggesting would be optimal. You can see on this page that there is a tapered arrangement of these coils. My understanding from watching their videos, they can change that geometry, fairly easily to test this with. So it'd be a fascinating place to see if we get improvement. You can see over here where my cursor is how they're doing experiments as they implode or push this into a smaller and smaller implosion space. So again, looks like another place where potentially, if this process were optimized with the 76.345 geometry, that we might be able to improve yields. So that's the end of this session. I want to let everyone know, though, that having worked on this now for probably 6 or 7 years, I've been all of this research that we've talked about today has been tied together very recently into a model that George Leoniak and I have put together. George contacted me about 3 or 4 months ago. He's a sacred geometer who loves to work with the platonic solids, and I had put together most of the facts that were necessary to develop a model. You can see the torus there on the bottom. It has this 76.345 geometry when the torus is spherical in nature. And we have developed a model now that links that geometry, fractal scaling, and the scaling of the platonic solids all within this toroidal model. So it's the first time that this has been done. If you're interested, this will give you a whole lot more theoretical background from the standpoint of sacred geometry, how the universe is organized, number one, and how this scaling implosion geometry really works. So if you're interested, go check that out as well. So anyway, I want to thank you for listening. If any of you have people within the fusion industry who you think might be interested in learning more about this, or if you're in the industry yourself and are hearing this and have more questions, please feel free to contact me. I'm going to be looking to possibly get this information to not only the Fusion Industry Association, but also to at least the 5 companies that I've determined so far might be able to benefit from it. So I would just say this: I thank you all for listening. If you have comments on this, please feel free to get in touch with me at Charlie@Stargate Pyramids, or my phone number 412-474-3481. I thank you for watching, and you have a great day.